A prerequisite before we start, you might need to know what thrust is. Thrust is basically a force that results from releasing an accelerating mass. An example is a deflating balloon, right? The accelerating gas that escapes the balloon produces thrust. That thrust is pointed downwards, so the balloon moves upwards. That's basically how thrust works, and that's essentially how most rocket propulsion systems works as well. This stage is usually the larger and heavier part of the spaceship, which carries the upper stage to Earth's orbit. It is currently limited to chemical propulsion because the other existing propulsion systems are unable to produce the thrust needed to get off the ground. Chemical propulsion works by ejecting accelerating particles, out the rocket nozzle, which produces thrust. I'm going to talk about liquid bipropellants. The first propellant, fuel, is usually RP1, aka kerosene without sulfur, or liquid hydrogen. You could also use liquid methane. And the second propellant, an oxidizer, usually liquid oxygen. Oxidizers are important because they allow the fuel to combust, which is very important for the chemical reaction. And when the propellant is mixed, they are ignited, and the products of this reaction is then sent out the nozzle, which produces thrust.
Now, when a spaceship reaches outer space, there are many different propulsion systems you can choose from. Yes, you can continue to use chemical ones, but they're heavy, they take a lot of space, and they might explode. And also, good news, there are 3 great alternatives: ion propulsion, solar sails, and nuclear thermal propulsion.
Ion propulsion systems work something like this. Xenon atoms enter the chamber and get hit by electrons from an electron gun. This will cause the xenon atoms to ionize, turning into a positive xenon ion while releasing 1 electron. The electrons are then collected in these positively charged walls of the chamber and are then released through another electron gun. With the help of magnetic fields, the xenon ions are then shot out at very high speeds, which produces thrust. Solar sails simply reflect light. The momentum from the photons will hit the solar sail and transfer some of that momentum, which allows the spaceship to move. Nuclear thermal propulsion sends fuel through a fission reactor core, which produces a lot of heat. This heat causes the fuel to become much more energetic. This heated fuel is then sent out the nozzle, producing thrust. Cold gas propulsion is most commonly used for maneuvering in outer space. Here's how it works. Pressurized gas is stored in a tank, and when a mechanism is triggered, it opens up a valve that lets the gas escape. This produces thrust that propels an object to their desired direction. And that's it for now.